viewers, after a long period I am posting this video in one of a forensic science field, one of the most important field, that is study of fingerprints. Fingerprint is also otherwise called as dermatographics. Fingerprint science is a positive means of identification and in the hands of knowledgeable technician and expert. It is a potent weapon in the continuing fight against crime. Fingerprint is one of the most important or vital evidences which is being found in a crime scene. In crime scene we will find two types of evidences. One is trace evidence, one is physical evidence. Fingerprint is one such in which we may get either latent fingerprint or a physical or a visible fingerprint. If latent fingerprint is to be traced, we have to use certain techniques which will be continued in our later class. Today first we will discuss about the fingerprint. In contrast, personal identification by means of fingerprints has an absolute certainty. The system is based on the undisputed fact that after so many studies that it has been found that no two persons have exactly the same fingerprint individual characteristics. Everybody will found astonished when you say that each fingerprint is individual. But everybody, some of our viewers are aware that there are basic patterns of fingerprints. If you see in your hands, somebody will say loops are there in my hand, in my parents, or example, if my father or mother, my siblings are also having loops or whorls or other patterns in their hand. But pattern may be same, but the individual characteristics, the minutiae or the minutiae characteristics which are found in fingerprints are unique, which makes your fingerprint individual and which makes it an individual character of your fingerprint, which makes us or which helps us to identify and individualize your fingerprint. Fingerprints are composite of the ridge outlines formed or reproduced when perspiring on non-hairy skin. The ridges are formed by the different patterns determined to distinguish identity, whereas on hairy skin the ridges are irregular, slender and intermittent and do not form any pattern. So if you see your hands, palm region of your hands and your foot, you will find the ridge lines. These lines are the one which makes the pattern. These ridge lines are the fingerprint patterned lines which makes or which creates the fingerprints of every individual. Generally these are like a gripper in our hand. If there were no any such ridge lines in our hand, it will be very difficult for us to hold upon any material. Even some of animals, our ancestors, which so far according to evolution of theory of evolution is concerned, some of the chimpanzees and apes will also have the same sort of ridge lines in their palmar region also, which helps them to hold the thing. The Jane Goodall, one of a famous chimpanzee researcher, has found that chimpanzees are very good at using tools because they are also having ridge characters. Because of these ridge characters, they were able to hold upon any materials in their hand, so which will help us to use or to hold the tool and use them accordingly. Dactyloscopy, the science that deals with the study of identification and classification using fingerprints. Gyroscopy, the scientific examination of study of the palmar region of the hand. Pedoscopy, scientific study of the sole or sole of the feet. Poroscopy, scientific examination of the sweat pores of the friction of the skin. These are all the important subgroups or sub branches of dermatoglyphics called dactyloscopy, as I said, and gyroscopy, pedoscopy, and poroscopy. A fingerprint or a finger mark is a raised area of minute ridges found on the surface of the skin of each finger. These structures are known as friction ridges. Friction ridges are found not only on the fingers but also on the palms of the hand, on the soles of the feet also. The scientific working group on friction ridge analysis, study and technology defines a friction ridge as a raised portion of the epidermis on the palmar or plantar skin consisting of one or more connected ridge units. The word palmar refers to the hand, the palms of the hand, finger joints and fingertips. The word plantar refers to the bottom of the feet and the toes. Friction ridges are similar in contour to mountain ranges. Just as mountains are pushed up through the earth crust to the surface, so too are friction ridges pushed up through the layers of the epidermis to the skin's surface. Though friction ridges all appear to be the same width and height when viewed under minimal magnification, they are in fact extremely variable. Friction ridges vary in width, height and contour. They are punctuated with sweat pores that also vary in size and contour. The evolutionary function of the friction ridge is in the word friction. In physics, friction is the measure of resistance when the surface of two objects are pressed together or when two objects are move against each other. Friction ridges are formed over thousands of years of evolutionary development. They are found not only on human hands, as I already said, and feet, but also on the hands and feet and prehensile tails of other primates. This was addressed in a thesis written by Johannes Purkinje, a Czech scientist who contributed extensively not only to the science of fingerprint analysis but also to the physics and physiology. Each fingerprint consists of a distinct pattern of friction ridges and dozens of minute characteristics. Latent print examiners and 10 print examiners utilize these patterns, locations and types of characteristics and other information from the friction ridges in order to determine whether the impression of unknown origin and impression of known origin may come from the same sources or not. If when in the fingerprint is got or obtained in a crime scene, it has to be matched with the sources or the suspects, and through which we will be able to identify both the fingerprints are of same person. Fingerprints have historically been touted as unequivocally unique. Recently, the broader scientific community has challenged this claim. How can fingerprint examiner make this bold assertion? As there is no way to compare every fingerprint in the world with every other fingerprint in the world, we can never prove absolute uniqueness. However, the historically established science behind fingerprint examinations, coupled with intrinsic variation in nature, contribute to the ability to express the conclusions of fingerprint examinations with confidence and scientific reliability. You may have heard the adage, nature never repeats itself. Natural variation is the notion that no two things in nature are exactly alike. No 2 ears of corn have been found to have the same pattern of kernels. No 2 zebras have been observed with the same pattern of stripes. No 2 cheetahs have been shown to have the same pattern of spots. and no two fingerprints have been discovered with identical configuration of minutiae. An understanding of the uniqueness of fingerprints necessitates an understanding of the physiology of human skin and the developmental process that create it. Human skin is not one homogeneous layer of tissue. It is a complex of many layers, each with distinct functions and morphologies. The skin is made up of three main layers: the epidermis, dermis, and a layer of subcutaneous fatty tissue known as hypodermis. The epidermis is the top section of the skin, stratified into 5 layers: the stratum corneum, the stratum lucidum, the stratum granulosum, the stratum spinosum, and stratum basal. Below the epidermis is a deeper layer of skin tissue known as the dermis. The basement membrane zone, also called the dermal epidermal junction, attaches the dermis to the epidermis. This zone is composed of fibers from the basal cells reaching into the dermis, as well as fibers from the dermis reaching towards the basal layer. Just like the roots of plant, the fibers anchor the layer together. The dermis is a thick elastic layer that contains the sweat glands, blood vessels, and nerve endings. Dermal papillae structure found in the upper layer of the dermis are peg-like projection pushing up toward the epidermis. The dermal papillae create a greater surface area for the transfer of nutrients from capillaries to both the dermis and epidermis. All these structures develop while the fetus is developing in uterus. Developmental process of fingerprints. In 6 to 7 weeks, webbing between cartilaginous finger begins to dissipate, volar pads appear. 7 to 10 weeks, volar pads grow. Volar pads vary in position, size, and shape. In 10 to 15 weeks, volar pads regression begins, where epidermal ridge cells begin to replicate in basal layer, primary ridges forms, sweat glands were also formed. In 15 to 17 weeks, secondary ridge formation initiates. The top layer of the epidermis forms. In 17 to 25 weeks, secondary ridges form between all primary ridges. Ridges are apparent on skin surface. Dermal papillae is being formed. Friction ridges have adult morphology. Ridge units are the building blocks of the friction ridges. Each ridge unit is composed of one sweat gland and a corresponding sweat pore. Friction ridges are composed of hundreds of ridge units, each fused to its neighbor to form a generally continuous structure. There are many factors that influence the development of each friction ridge unit. The fusion of various friction ridge units result in a diversity of primary ridge structures and morphology. The width and height of each ridge unit are variable, resulting in friction ridges that are not smooth but contoured like mountain ranges. There is variation in the width of ridge units. The depth of ridge penetration into the dermis, the alignment of the units, and the spacing between the ridges are the one which makes the ridges variances. The placement, shape, and size of the pore on each ridge unit are also distinct. The three-dimensional morphology of each friction ridge unit results in distinctive structure. Fingerprint patterns form as a result of volar pad morphology. Low volar pads from arches, high volar pads from whorls, and volar pads that are of center form loops. However, fingerprint patterns are not unique structures. The uniqueness within the pattern is found in the small details, the types and location of minutiae. you will recall that there are three types of minutiae: bifurcation, ridge endings, and dots. As Hale states, one of a major researcher in the field of fingerprints, the minutiae are the products of the interaction between stress and the ability of ridges to multiply, as well as the chronology of their origin. Without random variability in friction ridge, development and minutiae formation, fingerprints would not be distinctive. The natural variation found in friction ridge is the result of the properties and mechanisms of differential growth. The following are factors that contribute to the development of volar-pads, ridge units, and minutiae, and thus to the uniqueness of fingerprints. They are like genetics, epigenetic factors, that is nutrition, position, environment, etc. Growth stresses due to differential growth, volar pad topography, that is thickness, height, width and contour, compression due to volar pad recession, metacarpal bone formation and morphology, timing and rate of ridge maturation, vessel nerve pairs in the dermal papillae. So far, today in this video, we have understood how fingerprint is formed. I hope everyone has understood and everyone is fine, doing well. We will meet in our next video. Until then, it's Janaki signing off from this video. Thank you for watching. Please subscribe the channel. Thank you.